So in this video, I just want to show you a few examples of graphing absolute value functions from start to finish. So number one gives you y equals 2 times the absolute value of x plus 1 minus 5, and they've asked us to pick out the vertex, the x-intercept, the y-intercept, graph it and describe the transformation, and pick out a, h, and k. Okay, so starting with the vertex, we need to pick out h is going to be -1, and k is -5. So you change the sign of that first number that's inside the absolute value symbol, and then bring down the one that's out behind it. Now let's start on the graph using that vertex. So if I go to -1 and -5, I go left 1 and down 5 to put my vertex. And then we're going to use this number in the front as our slope. So it's +2, so I need to go up to right 1 in each direction. So up to right 1 and up to left 1. Remember, these graphs look like a V-shaped graph, and they're symmetrical. So that helps you to sketch a graph. So then we have enough to graph our V-shaped graph. We can easily see the x-intercepts look like they are between 1 and 2. So let's say 1.5. There's one right there. And then this one is between -3 and -4. So let's say -3.5. And the y-intercept is right there. So let's say that looks like -3. Now let's describe the transformation and label A, H, and K. So the transformation in this case shifted left 1 down 5 from our graph. So you can tell it went left 1 and down 5 when we graphed it. So let's say left 1 down 5 units. And then that 2 that was out front made it have a vertical stretch by a factor of 2. So let's write that. Vertical stretch. Sorry, my pen is so sticky. By a factor of 2. So the A value in this case is that number right out front, which was the 2. Because remember, our standard form is y equals A times the absolute value of x minus h plus k. So A was 2, h was -1, and k was -5. Let me write that better. Okay, so let's look at example 2. We have y equals 1/3 the absolute value of x minus 1 plus 2. So when we pick out the vertex, we want to change the sign of the 1 in the absolute value symbol, our h. So make that +1, and then the 2 is just going to be the same. So let's go ahead and graph our vertex. So 1 is right there. And then we're going to use this number in the front to help get some more points. So 1/3 is like a slope. It's positive, so we're going to go up 1, right 3. And we're going to go up 1, left 3. Because we just need that nice upwards facing V-shaped graph. Okay, so we can tell that there will be no x-intercepts for this graph. The y-intercept looks like it's between 2 and 3. Let's estimate like about 2.2 maybe. And then describe the transformation. So this one shifted from the origin, right 1 up 2 was our shift. Right 1 up 2 units. And then the 1/3 that's right out front made it have a vertical compression by a factor of 1/3. So let's say vertical compression by a factor of 1/3. And the last thing to do is pick out A, H, and K specifically. So A is the number in the front, which was the 1/3. H is the number inside the absolute value symbol, but change the sign when you pick it out. So that was +1. And K was the number in the back, which is 2. And that is it for that one. Let's take a look at number 3. So number 3 says negative absolute value of x plus 2 plus 3. So our vertex, we're going to pick out negative 2, 3. Let's go ahead and graph negative 2, 3 to help us get this on our graph. And then a negative in the front means we're going to go down. And it's like a negative 1 right there. So go down 1, right 1. And then down 1, left 1. Because it's a V shape again, the spacing down. Okay, so now let's see what the x-intercept is. There is no x-intercept for this graph, so none. Y-intercept is clearly at negative 1, 2, 3, 4, 5. So negative 5. You can also write it as an ordered pair. So 0, negative 5 is another good way to write that. And describe the transformation. So it shifted. We can either look at our graph at this point or go back and look at our equation, whichever is easier for you. It shifted left 2 and up 3 units. And then the negative in the front meant that it reflected over the x-axis. So it reflects over the x-axis. And then let's just pick out A is negative 1. Let's say H is, where'd it go? H is negative 2 and K is 3. Okay, so let's look at one more example. Number 4. Number 4 is 2/3 the absolute value of x plus 4. So our vertex in this case, let's rewrite this for a minute. It's like saying 2/3 of the absolute value of x plus or minus 0 plus 4. So your vertex has 0 in it this time. So 0, 4 would just be up 4. Then 2/3 is how far we're going to go to get some more points. So it's a positive 2/3. So go up 2, right 3. And on the other side, go up 2, left 3 from your vertex to have a nice symmetrical V-shaped graph. Your x-intercept is at 4. So you could say that's 4, 0 as an ordered pair. Or excuse me, that's your y-intercept, not your x-intercept. Sorry, let's put that down here. That's 4, which is 0, 4. And again, on this example, we have no x-intercepts because it didn't cross the x-axis. And describing the transformation, the graph just shifted up 4 units, and then it has a vertical compression because of the 2/3 being less than 1. So we're going to say vertical compression, write all that out, by a factor of 2/3. Okay, the last thing to do is pick out A, H, and K. So A in this case was the 2/3 in the front. H is just 0 and K was 4. Alright,